Hello again. Welcome to another Wonderland creation. Today we're going to look at some more complex angle puzzles. See how we can start putting all these things together. We've talked about things like vertical angles and supplementary angles that form linear pairs. We've talked about parallel lines and the relationships that they create, alternate interior, corresponding, alternate exterior. We've talked about triangles and their interior angles having a sum of 180, and we've talked about triangles and an exterior angle, where the exterior angle is equal to the sum of the two remote interior angles. All that kind of comes together in these problems. The puzzles get more complex. You have to start recognizing the different things you can see. So let's start with this one. I have 5 examples total here. The following diagram, line BC is parallel to line DE. And you can see the little parallel markings here, and right here, saying that these two lines, BC and DE, are parallel. So you know, once you see parallel lines, you're talking about creating some parallel line relationships because we have some transversals. This FC is a transversal, or BA is also a transversal. It's just a smaller transversal. So I see 2 ways to solve this. I'll solve them both ways just so you can kind of see both ways. First of all, we're looking for angle X right here. So angle X, well, that's on the outside of this triangle, but it's not an exterior angle because it doesn't come with a straight line with either of these, so it doesn't help. But I see that X and 109 and this blank space angle all together form a straight. All three of these together would form a straight 180. So if I can find this piece over here, I can use that with 109 to find X. Well, I can find this piece because I can look at alternate interior. If BA is my transversal, 42 up here and 42 down here are alternate interior angles. And now I can use that as a straight 180 to find out X. So I've got the 109, which is in the middle there. I've got the 42 on the left. Add them together and get 151. And then subtract that from 180. And I will get, let's see, 9, looks like 29 degrees. Looks like X is 29 degrees. That's option A. Option B, I'm going to leave that there. Actually, I'm going to erase all that. Remember, we got 29 degrees. I'm going to change my color here. I'm going to do it again. Option B is I see that angle X is alternate interior to this angle up here, which means they'll be congruent. They'll be equal to each other, with FC being the transversal. And I see that this angle is one of the 3 angles on the interior of this triangle. So if I've got 2 of the 3 interiors, I've got a 109 and a 42. These numbers look familiar, huh? That gives me a 151. And then the 3 interiors of a triangle make 180. So subtract that from 180. And it still gives me, as my final answer out here, 29 degrees. So you're looking at different relationships, different ways. Sometimes there's more than one way to solve the same problem based on relationships you see, and that's okay as long as your relationships follow the theorems and the rules that we've discussed. You can't just make up relationships. As long as it follows one of the rules that we've looked at, you're okay. Ah, the star. You want to find the measure of angle X. Oof, that is a messy looking star. But if I look at this star and I'm able to dissect it, I see triangles in the star. Okay, so like X is part of a triangle here, this little triangle between G and H and C, but I don't know G here. I don't know C here, so that's not going to help me. But X is also supplementary with this angle next to it. They form a straight 180. This X, this angle here, makes a 180. So if I can find this angle, I can find X. Well, how am I going to find the angle in there? I have to dissect. I have to pull apart this shape. I see a triangle. I see angle 31 degrees down here. I see 47 degrees here, and I see a missing angle there. So here is my triangle. There to there to there. There's my triangle. So I got a 47 up top and a 31 on the bottom. Add them together and get 78 degrees. And now because the sum of the interiors makes 180, I subtract that from 180 minus 78, and that is 102. This is 102 degrees. And now the 102 and the x makes 180. They're a supplementary straight pair. So 180 minus 102, 78 degrees. 78 degrees. Or if you were really, really paying attention, you would see that this x, let me erase some of this stuff here real fast. Let me erase this guy, erase that guy. There we go. You would see that that x is an exterior angle because it's still continuing straight right here. It's an exterior angle of this triangle. And then here's the adjacent angle, which means that this 47 and this 31 are remote interiors. So the two remote interiors have a sum that equals the exterior on the other side. So you could have just done 31 and 47 and gotten 78 as the exterior angle being the sum of the two remote interiors. You'd recognize that. That's tough to see in a very complicated diagram with lots of different moving, missing parts. But if you can see it, fantastic, use it. All right, let's keep on moving. Line DE and FG are parallel. So DE and FG are parallel. Okay, that's good. Create some alternate interiors, correspondings, that kind of thing. And KL and FG are perpendicular. There's the perpendicular symbol. So KL comes down here and forms a bunch of rights. That's going to help. That's going to give me some 90s. So you know what I'm going to do? I'm going to go in here and I'm going to fill in some 90s. KL makes a bunch of 90s. There's a 90 there. There's a 90 there. I'm not going to fill in the 90s here because those 90s are broken up. But I'm trying to find X up here. That's way out in the top. But this X here is also vertical to this spot right here. So the X on the top will also transfer down to become an X here. This is also X because it's vertical to that X. And now I got an X here. I got a 90 there. I'm going to color code all this nicely. I got a 90 here. And I have a blank angle here, but that's vertical to this one. So this 63 is vertical to that one. So I'm going to transfer this 63 across the vertical to right there. And now I got myself a pretty simple problem from there because I have a triangle on the inside. See my triangle right here? Boom, boom, and boom. I've got a 90, I've got a 63, that gives me a total of 153. And the interiors have a sum of 180. So 180 minus 153, that's a 7, that's a 2. It looks like X is going to be 27 inside, so it's also 27 on the outside. Always look for those verticals. The verticals are so clutch and so easy to see. All right, got two more. H, I, and J, K are parallel. We don't like those when the parallel lines are crooked. Those diagonal lines coming through here are parallel. If it helps, tilt your head, tilt your computer, do whatever you got to do to see those parallels and how they're related. So I've got an X here. I've got a 66 here, and I see myself a very basic little triangle where I've got 2 out of the 3. I've got 66 and X. Can I find this one? Well, based on parallel, I can. Because based on parallel, this 62 right here is corresponding to this 62 right there. And now I got myself a triangle with two numbers and an x. And I'll use the triangle interior sum of 180. So I got a 66, I got a 62. That gives me a 128. And then subtract that from 180. That's a 2, that's a 5. That looks like it's a 52 degrees angle. It's pretty good. Okay. And last but not least, I saved the easiest one for last, actually. I know it's not like me. I usually save the hardest for last. A basic exterior with some remote interiors. Remember, the rule is the exterior angle, 116, is equal to these two remote interiors added together. Remember, I ignore this guy. I ignore this guy because that's an adjacent to the 116. I look at the two remote interiors away from the exterior, and I know that they add to make the exterior. So I know that the x and the 60 have to add to make 116. Well, you can write an equation and solve it, or you can just say, well, if I know the total is 116, I know one part, I can take 116, subtract away the part, which is what I would do if I solved the equation. I would subtract 60 from both sides. Same process. And let's see, that looks like a 56. X looks like it's 56 degrees, which makes sense. As an acute angle, even though it says they're not necessarily drawn to scale, they'll still be close enough where if it's obtuse, you're going to get an obtuse looking picture and an obtuse measurement. It may not be the exact measures, but if it's an acute angle, it's going to look like an acute angle and you'll get an acute measurement. All right, so there you go. Taking all of these things we've talked about and trying to continue to piece together this puzzle, finding all the missing angles. Good luck.